This is a video series for our first week of Math 290 with numbers and operations. So we're going to look at operations with fractions in this first few slides here. So in order to work with with fractions and adding and subtracting fractions, a key component is having the same parts. And so we're talking about denominators. So when we're talking about that, we're thinking about the least common multiple. And so ways that we can find the least common multiple, we can certainly list our numbers out, which is equivalent to skip counting. So we would skip count by fours, 4, 8, 12, 16, 20, 24, and so forth. And then 5, 10, 15, 20, 25. And what you're looking for is what's the lowest multiple that they have in common, which would be 20. All right, we'll do the same for 6 and 8. Skip count by 6. And this is the same as 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5, 6 times 6. And then with 8, we've got 8 times 1, 8 times 2, 8 times 3, 8 times 4. And so we see that our minimum, which is what our least common multiple would be, and that is your lowest multiple of 6 and 8, which would be 24. Now if we look at some context with adding and subtracting fractions. So Kay practiced the guitar for 2/3 of 1 hour. And when she's finished, she practiced piano for 3/4 of another hour. How much time did Kay spend practicing her instrument? So it's looking for a total. And in order to find that total, we need to find an LCM of 3 and 4. And so we're looking for basically an n divided by n ratio that's going to allow us to get to an equivalent fraction. And so 2/3 we would multiply by n divided by n, which would be 4 divided by 4. And 3/4, our n divided by n would be 3 divided by 3. The n divided by n that I'm talking about is equivalent to 1. So when you're multiplying 1 times the fraction value, you do not change the value. That's your identity of multiplication. So 2/3 times 4/4 would be 8/12. 3/4 times 3/3 would be 9/12. And so now with the same parts, with 12ths, we can add our numerators, and 9 and 8 give us 17. So I would take 17/12 as an answer, 17/12 of an hour, or we can change it into a mixed number and just divide, and we would see we'd have 1 and 5/12, so just a shade under 1.5 hours. Penny used 2/5 of flour to bake a vanilla cake. She uses another 3/4. How much did she use altogether? So again, we're looking at an LCM of 5 and 4, which we would say the LCM would be 20. So my n divided by n would be 4 divided by 4. So this would be 8/20 plus 15/20, which would be how many 20ths? Well, you add the numerators and you're going to get 23/20, or 1 and 3/20. And what this is to think about the units. This is pounds of flour. So another example, so I've got 2/3 plus 1/2. The LCM would be 6. So we would multiply this by 2 divided by 2, and this one by 3 divided by 3. So this would give us 4/6 plus 3/6, or 7/6, or 1 1/6 as an answer. Now when you have your mixed numbers like you see here, 2 2/3 plus 2 1/4, I would encourage you to go ahead and add the whole numbers together. So that would give you 4, and now you're adding the 2/3 plus the 1/4. And since thirds and fourths, we would multiply this by 4/4 and this one by 3/3. And so that would be 3/12 and 8/12 and 4 wholes. So this here would be 11/12 plus the whole number. So we would have 4 and 11/12. So Mr. Penman has 2/3 liters of salt water, and he used 1/5 of a liter for an experiment. How much salt water does he have left? So this is going to imply subtraction. So our LCM would be 15. And so we would think about what we would multiply by. So this would be 5/5. This would be 3/3. So this would be 10/15. Take away 3/15. And that would equal 7/15 liters remaining. George says that to subtract fractions with different denominators, you always have to multiply the denominators to find the common unit. So this 3/8 minus 1/6, sometimes you can do that. It doesn't mean that you always need to do this, because in this case, 8 times 6 is 48. But the LCM would actually be 24. So if we get 3/8, and if I multiplied by 3/3 and 4/4, that would give me 4/24 and 9/24, which would subtract to get 5/24. Now, if we look at what George was talking about, 18/48 take away 8/48 would actually give you 10/48, which is equivalent, but if we divide, so if we want to simplify this, we would say 2 times 5 and 2 times 24. And here's your common factor that would divide out. And then what you're left with is the 5/24, which is equivalent. So no, you don't always have to multiply the denominators. If you're having trouble finding a common denominator or a multiple at times, you can, but sometimes you will not come up with the smallest, so therefore you would need to simplify. And that was the case with George. He did 8 times 6 and got 48, which was fine. He just needed to simplify that result, which was 10/48. He was just going to have to simplify that fraction to get to the 5/24. So here we've got 3/4, take away 1/3. So an LCM would be 12. It would be 12, so I would multiply by 3/3 and this one by 4/4. So that would give me 4/12 and 9/12. And 9 minus 4 would be 5/12. And I can't simplify that anymore, so I'll leave it. Now 5 3/5 minus 2 1/3. So in this case, I need to find And that's just a way that I like to, when I have to subtract that, is I just like to see it vertical. And you can, of course, work it horizontally like that. That's not a problem. But I'll need 15ths. I'm going to multiply this by 5 divided by 5 and 3 divided by 3. So that'll give me 9 15ths and 5 15ths. And I can subtract this without going into the negatives. 9 15ths take away 5 15ths would be 4 15ths. And then the 5 take away 2 would be 3. So I would get 3 and 4 15ths. So that's your, when you're looking at adding and subtracting fractions, you certainly want to have a common denominator, a least common multiple that would allow you to work in the same parts. Now the key, remember, is to get your equivalent fraction. So you may have to figure out what your n divided by n would be in order to do that. So now let's look at multiplying and dividing fractions. So we can think about a rectangular model to represent this. And if I want 3 times 1/4, or 3 dot 1/4, or 3 in parentheses 1/4, what this is actually, with a whole number multiplied by a fraction, you can think of, you want 3 groups of 1/4. So that would be 1/4 plus 1/4 plus 1/4, which would be 3/4. Now, a common error, let me just state, a common error to this is that students want to multiply 3 by 1 to get 3, and 3 times 4 to get 12, and notice your answer is 1/4. Nowhere near the result that's 3/4. So there's your common error with that, and just be mindful that you're not multiplying the whole number by the numerator and denominator, but just the numerator. Or you can think of it as, if it's a whole number, think of it as how many of those groups of that fraction. You can also look at it as an area model. So if we want 2/3 of 3/5, I know it's already drawn, but let me go ahead and draw it so where you understand how it's being split up. So 2/3 of 3/5. So I'm going to split my rectangle into fifths, and I want 3 of them. So I want 3/5. So here everything is in fifths, and I wanted these 3. Now, of that, notice I said of that, of that 3/5, I want 2/3. So therefore, I'm going to need to divide the left side into thirds, and I want 2 of them. So that's of the 1/5. So I'm only shading of what is in yellow. And so since the horizontal sections are representing thirds, now I look at and see, well, what was highlighted? That's 2, 4, that's 6 out of the total. And the total was a 3 by 5. And so that would be 15, which we can simplify. 6/15 would be 3 times 2 and 3 times 5. So here's your common factors that would multiply out. So you're left with 2/5. Now another way to get that without doing the area model is 2/3 multiplied by 3/5. You can take, let me just go to another page. You can take 2/3 times 3/5. So one way to do this is to multiply across. 2 times 3, I get 6. 3 times 5, I'm going to get the 15. And so that would simplify, like I said, to 2/5. But notice up here, I was crossing out these factors of 3. Well, over here, I rewrite it, we can sometimes look diagonally and think, well, I see these factors will actually divide out. So then what you're left with is just the remaining factors. You can also think of it as 2/3 times 3/5 and use the commutative property and switch these around and look at it as 2 times 3 divided by 5 times 3, and then this will divide out, leaving you with 2/5. And that's the idea up here where you're listing the factors of 6 and the factors of 15 and seeing what you can divide out. So 3/4 of 4/5. If you'll notice, I can use the commutative property and switch the denominators and make this 5/4, and notice that these will divide out and you're left with 3/5. You could also multiply across and say 12/20, and then think of your common factors. That would be 4 and 3, 4 and 5, and the 4s divide out, leaving you with 3/5. Part C, I've got 2/5 of 2/3. So I could multiply across and get 4/15, and 4 and 15 do not have a common factor, so it would be simplified. Looking at another one, 4/5 times 2/3. 4 times 2, I'm going to get 8. 5 times 3, I'm going to get 15. I still do not have a common factor of 8 and 15, so I'll leave it as is. And then 3/4 multiplied by 2/3. I can look diagonally. And one way to do this is to see that I could draw one division bar, and then you would see that those factors would divide out. You're left with 2/4, and 2/4 would be the same as 1/2. Another way to look at that is if you wanted to use commutative property, so this would be 3/3 multiplied by 2/4. Well, the 3 factors of 3 divide out, and then 2 actually divides 4 2 times. You're left with a 1 remainder in the numerator, so you're left with 1/2. So different ways that you can simplify your fractions. Most common algorithm is that you're multiplying the numerators and then you're multiplying the denominators, and then you're going to simplify. And so Melissa delivered 3/8 of the newspaper on her route in the first hour and 4/5 of the rest in the second hour. What fraction of the newspaper did Melissa deliver in the second hour? So we'll have 3/8 of the newspapers on the first hour, and then we're going to take 4/5. Or we could say there's 3/8, and then we're going to take 4/5. Well, 4 will divide 8 2 times. And so now I've got the 1 times 3, which is 3. 5 times 2, which is 10. So I'm going to have 3/10 of an hour. In the second hour, 3/10 of the newspapers. You've got 3/8 times 4/5. You could multiply across and say 12/40. You would just need to simplify that, both with a factor of 4. See, the 4s divide out, but we also noticed that a 4 was dividing out with a factor of 4 in the 8, so we still get 3/10. All right, let's look at our last piece, which is with division of fractions. And division of fractions, there's a couple of ways to work this. When you're looking at 2 divided by 1/3, you're figuring out your whole amount, and your whole is a 2-unit block here. and you're just trying to figure out how many thirds would fit into 2 wholes. Another way to write that is as a complex fraction. So you're just thinking how many thirds will divide 2. And a lot of times students get this mixed up with 2 divide 3. And these are not the same. They will definitely yield 2 different answers. So when you have 2 divided by a third, one way to do that is you can use a common denominator. So you could think, well, I'm going to multiply by 3 divided by 3. So that'll be 6 thirds divided by 1/3. And so 3 divided by 3 is 1. 6 divided by 1 is 6. So your answer is 6. That's how many 1/3 would fit. And we could see that here in the drawing. 1, 2, 3, 4, 5, 6 1/3. And then, so that's where we're seeing that there are 6 thirds in 2 wholes. So if we have 4 divided by a half, well, we're saying that there's 2 halves in 1 whole. Then there are how many halves in 4 wholes? So that would have to be 8 halves in 4 wholes. So this 4 wholes would hold 8 halves divided by 1/2, which would be 4. And so if 4 is half, in this case, then we would say 8 would be the whole. And then if we've got 2 divided by 1/4, we're just seeing how many 1/4, how many fourths are in 1 whole, and that would be 4. So how many fourths are in 2 wholes, and that would be 8. So we'd have 8 fourths divided by 1/4. So we would get 8. So if 2 is a fourth, then the whole would be 8. So a principal orders 8 sub sandwiches for a teacher's meeting, and she cuts them into thirds. And so we're just trying to figure out how many mini subs onto a tray and how many would she be able to serve if she just ordered 8 sub sandwiches. And so this would be that how many thirds are in 1 whole? 3. How many in 8? It would be 24 thirds. And now 24 divided by 1 is 24. Another way to do this is using your reciprocal. And so 8 multiplied by 3 would also give you 24. We can look at that as the ones in the previous one. So 2 divided by 1/4. Our reciprocal would be 2 times 4 to 1. Notice I'm taking the reciprocal here. The reciprocal of 1/4 is 4. So 2 times 4 would give me 8. So I still get the same answer. All right, so by any method you would like, so if I have 3/8 and I want to divide it by 3, I could use the reciprocal method and do 3/8 multiplied by 1/3. I could switch these two and make it 3/3 multiplied by 1/8. Those would divide out. Your answer would be 1/8. If you wanted to use common denominators, how many thirds or how many eighths are in 1 whole would be 8. So how many in 3 wholes? And so this would be 24 eighths. So 8 divided by 8 is 1. 3 divided by 24, you get a fraction. So it's 3/24, which would simplify to be 1/8. So we get the same answer there. And then the next one, 3/4 divided by 1/5. In this case, I don't have a whole number, so I am thinking about what would be my lowest common multiple if I want to choose that method, and that would be 20ths. So this would be 5 divided by 5, 4 divided by 4, so this would be 15/20 divided by 4/20. So now that I have the same denominators, I would just look at the numerators and say 15 divided by 4, which would divide 3 times. So it would be 3 3/4. Or I could take 3/4 and multiply it by the reciprocal of 1/5, which would be 4. And then I could multiply and get 15/4. Notice I'm going to get the same answer as before. One half divided by 3, I could use 1/2 multiplied by the reciprocal. 3, the reciprocal is 1/3, so my answer would be 1/6. If I want to use the denominator method, how many halves are in one whole would be 2, so how many halves in 3 wholes would be 6 halves, so 1 divided by 6, same answer. And then 1/2 divided by 4/5 would be multiplied by the reciprocal, so you would get 5/8. So that'll conclude our first video about operations with fractions. We looked at adding, subtracting, multiplying, and dividing.